this look like about everybody? We're still waiting for some people. Are we? Are we? Okay, we'll give it maybe like a minute or two so it looks like it's their fault instead of mine. Hmm. Cool. There we go. Okay, I think that's probably about as long as I want to wait. Thanks for hanging in there, everybody. Who knows what we're talking about today? Promises? Web development? Good answer. I mean, you were here. Like I told you, like 10 minutes ago, what we were doing. You're technically correct. We are talking about web development. So we're talking about promises and we're talking about errors in the exact opposite order. Um, so we're starting off with errors today. Hey, no worries. Um, so who here's had an error before writing code? It's more of a check to see who's listening. Right. Yeah, if you haven't seen an error before, it's because you haven't programmed before. I think like probably your first try with programming, you had more errors. Yeah, like error, 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 and then hopefully you figured something out and got going. So are errors a bad thing? Are they an obstacle to overcome? Why do we have errors in our systems? Yeah, the errors tell you what's wrong. Um, so assuming it's possible for something to be wrong, then when something is wrong, we'd like to know about it, right? Before we had complex systems to tell us specifically what and where our code is going wrong about. That's not a very good sentence. Um, your program would just crash and you wouldn't know why. You'd get some opaque answer about like I had a thing this big and you tried to fit something this big into it and that didn't work and I don't know what to do. Go home. But intrepid developers, language developers, found ways to give us different tools that layer on top of each other to give us insight into where exactly things are going wrong. So there are a few different places that errors come from. Does anyone have any examples? Where do errors come from? Hmm? Bugs in your syntax. Yeah, yeah. So syntax errors. Yeah, syntax errors are a big category of errors, right? Especially when you're first learning a language. Syntax errors are often the way things come up, and often when you have like typos and things, they manifest as syntax errors. Sometimes semicolons, yeah. JavaScript's actually really lenient about semicolons, right? Semicolon, no semicolon. It's not too worried, but a semicolon in the wrong place, that'll ruin your day. Yeah, so um, a syntax error is often the first error that you run into, right? So where does that error come from? The console? Uh, the logic, the language. From the cloud. From the compiler, I heard. Uh, yes, very close. But in JavaScript, we have an interpreter. So it's the JavaScript interpreter that gives you the error. If you're using a compiled language, then yeah, you can get compiler errors. So in other words, when you try to run your code, first it has to translate the code into something else, like maybe VM code or machine code. And during that process, errors come up where the compiler can say this isn't right. In JavaScript, most of our errors are that come from the interpreter are runtime errors. So over here, I have a node console. Let's see if we can cause a syntax error. What should we try? Keyboard mash. What's going to happen when I hit return here? It's not going to recognize this as a comment for sure. What's it gonna think that this line is here? Pardon? A string? A variable? Yeah, yeah. So before I answer, let me find out what the answer is, and I'll act like I knew all along. Um, so some of us said that I heard some people say that we'll get undefined. That turned out to be just ever so slightly wrong. We got not defined. And JavaScript, there's a big difference. Undefined is a value. Um, yes. Can I make it a little bit bigger? Too big? Back a little bit? I don't know. I like it there. How's that for the people furthest away? Okay. Um, so yeah, in JavaScript we have undefined and we have not defined, and those are very different concepts, right? So if I go, let's say, ASDF contains undefined, but if I go, core is not defined. So in this case, yeah, the JavaScript interpreter went looking for something in the environment. You know how if you go in Node, if you go process, you get all this stuff that's your environment. In the browser, you can go window, and that's your environment. It goes looking in the environment for did I import anything with that name? Did I declare a variable with that name? What is this name? And then it doesn't find anything. It says I tried looking for that thing you referred to and I couldn't find it. It's not defined. So just get that one again. So in this case, the node interpreter tells us what type of error it is. It tells us the particular thing that went wrong. It's missing one thing that we usually want from a good error, and that's where it happened. And part of the reason for that is because we're in a REPL. So the place that the error happened is on the line you just typed. But if we jump over to a JavaScript file, this is just a plain empty JS file, and we try something like that. What's the difference? Mm-hmm. There's information. There's more information. So we have the same thing right here, right? But it tells us more stuff. It tells us, it gives us a pretty detailed history of whose fault it is. So in the REPL, it's a very straight line. It's, you know, the user typed in something that was wrong, and that caused an error. In when the interpreter is running a script, there's more going on, and you can trace back a history of what exactly went wrong, right? So does anyone know what this is called? What this blob of at object anonymous at module compile at object dot module dot extensions. Does anyone know what all this stuff is? One more time. Stack stack error. Close. This is a stack trace. So this certainly refers to the stack, the call stack, right? So what's a call stack? Is anyone familiar with that concept? Okay, good. So you've heard of the call stack. That's a good start. So let's dig into that a little bit more and talk about what the call stack is. When your code runs, you have this chain of like a program invoking another program, invoking a procedure, invoking a process. You have things calling things, calling things, calling things, and that's called the stack. So in your application code, your stack trace might look something like, suppose you have a jQuery app. That's a thing, right? I don't write a lot of jQuery these days. Does that look good to everybody? Okay. So you have something like this. Then suppose you have a bunch of users, and this comes from somewhere else. So we're black boxing that. That's why I'm doing this fake require thing. So we might do users for each user. What should we do to users? True. Thank you. What do we want to do to users? Maybe we have a function that creates like a little profile card for them. Right? So now we have something of a stack, right? So we have some function called this, and it takes in a user, and it does some stuff, right? So if we have an error here, we put in some garbage here, then what we'll see happen is we get a trace of where the thing happened, right? So this happened inside of this function, and this happened inside of this function, right? This anonymous function that we passed for each. And this function happened inside of this function, right? For each is a function that takes a function as a parameter, right? And this happened inside of this function, and so on and so forth as we kind of go up the stack until we get to the parent process, right? The interpreter itself. So in this example, this was just at the very top level. It was the only line in the file, right? It wasn't nested inside some kind of function. So what did we get for the stack trace? Are there any hints in there about what's going on? Mm. Right. Um, right. So I'm going to refine that observation a little bit. We see that when we look at what's going on, we have object anonymous. This is a file we recognize, right? Like this is a path to something that's plausibly this file. This is called demo.js in this directory. Looks good. And then we're looking at something called internal. We see all the rest of the way down, it goes internal, 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 and we see all these kind of like esoteric things that we didn't create, right? So what we know from this is that something happened on this line, and then all of this stuff was involved in running the script to get to the point where we could trip on that error, right? And in truth, this stuff isn't that useful. Well, actually, this line is useful. These ones just tell us that it happened when we were running Node, right? So for the most part, unless we're doing something really spooky, we can ignore this stuff and just look at the lines that refer to files that we recognize, that we care about. Um, so the call stack becomes a lot more interesting when we're actually doing something like we're nesting functions inside of functions. Like, say the user is just a name. That's my name, by the way. I didn't mention that earlier. I mean, what we'll return is just a string. And then maybe we just pop that into like some other JavaScript that puts that on the page for us. This is a pretty boring profile card. I'm going to change this to username. It's a bit better variable name. So if I run this, then well, we want to see something happen, of course. So what do we expect to happen now? $sign is undefined. Interesting. Any other theories? Yeah, we just get the string back. So I suspect that that your theory was based on not having seen string interpolation before. Oh, I see. Oh, you thought okay, you saw this and thought jQuery. Okay, I see. Yeah. Okay, fair enough. So is anyone unfamiliar with this syntax? Template strings and string interpolation? Does anyone want me to talk about that? Make the screen a little bigger? Okay. Good? Cool. Um, okay, so I'm hearing that we've all seen template strings before. Let's move on. Okay. So yeah, so this function does what it's supposed to, right? The whole script does what it's supposed to. We get this string with my name in it. But let's say when I did that rename, I forgot to do this part, right? What's going to happen now? I heard user is not defined, and I heard user is undefined. So this is that undefined, not defined thing again, right? Um, so if user was, so like let's suppose that what we did was we passed nothing to this function. The function would declare this variable. The value of this function of the variable of the parameter would be undefined, and then this would just like print out undefined, and it would be fine. Or to print out empty string. I want to know. It prints out the string undefined. Okay, good. Mystery solved. But in this case, it's expecting a token to be called user, and it looks around and it doesn't find one. So it's not defined anywhere. It's not that it contains the value undefined. It's that it hasn't been defined anywhere. So we get user is not defined. Good guess. But now the stack trace looks a little different, right? So the way we look at this is we look at the first thing and we go, yep, I know what that is. And we look at the second thing and we go, yep, I know what that is. And then we look at this thing and we just see this word internal and we go like, okay, so the answer to what's going wrong here is probably not that there's a problem with the node compiler. If that's your problem, you have big problems. So let's look up here. So we focus here on files that we know about, that are specific to our application. Um, and what do we see here? What do we make of this? There's an error on line 4, I heard. It was caused by an error on line 7. Something like that. So that's, if you didn't know, this refers to the line number and the character number. So yeah, on line 4, something went wrong, and line 7 was the thing that called the thing that went wrong. So it's not that there was an error on line 7. It's that the error occurred while line 7 was doing whatever line 7 does. Right? So there's this thing that happens where on line 7 we have console log runs, and it notices that its parameter is a function, so it calls that function, right? And so while this function is running, line 7 is kind of waiting around for that to finish and come back. So when the error occurs here, it looks here and it says, okay, well, where was that called? That was called out here. And what called that? Well, this console log received it as a parameter, and we were trying to evaluate that. And while that was happening, we found a token that we didn't understand, and that's where things went wrong. So yeah, often what's going on is the actual problem, the place it blew up, was here. But sometimes the bad thing that happened was here. Like maybe we passed it a bad parameter, right? It's kind of hard to do with a string because JavaScript just turns everything into strings. Let's change it to a number example. Actually, let's say maybe it's like a Reddit thing, right? And we're going to compute the score. We have upvotes and downvotes. And how do we compute the total score of a post? We have upvotes, downvotes. We want to know the score. Yeah, we just want the difference, right? So upvotes minus downvotes. So far, so good, right? Okay, and maybe what we do is we say 40 upvotes and 10 downvotes. We don't need that anymore. Oh, nothing happened. I do need that log after all. Okay. So far, so good. Everybody believe me? Does this function work? Cool. So what's going to happen now? Not a number, type error, reference error, unerror, okay. We get out not a number. So here's a fun trivia fact. Remember how we were talking about the early days of computing, and nobody had really like invented errors in the way we think of them today? Most of computing was oriented around numbers, moving numbers around. Sometimes numbers would represent letters, and sometimes numbers would represent pictures, or like dots on a dot matrix printer or something. Sometimes a calculation would go so catastrophically wrong that if you got back this value, you should just go, okay, just stop everything we're doing. Like something bad has happened. And that value, there was like a particular bit pattern that if a calculation went wrong, you'd get this bit pattern out. And that bit pattern was called not a number. So there's a bit pattern that represents the number 1, 2, 3, 1,000, 10, 1024. There's a bit pattern that, if you look at the ASCII table, this bit pattern maps to the letter A. And there's a bit pattern for not a number. And basically what that means is something's gone catastrophically wrong, you should bail out. So not a number is kind of like this this pre-error error, like an error that predates the stack trace, predates line numbers, predates syntax errors. Not a number is kind of like a spooky kind of error. What happens if you subtract an object from an object? Is that just also not a number? Yeah, man, JavaScript's amazing. Let's go back to our 4D10 example. And let's say now we have a bunch of these. And what we're going to do is iterate over each one. And we're going to iterate over each one, and we're going to try to get the scores for each one, right? Everybody follow so far? We're going to go through each one of these, and we're going to look at the first thing, and that's our upvotes, and the second thing, that's our downvotes, and we're going to compute the score. So that looks good. But we noticed that JavaScript doesn't seem to mind if we subtract things that aren't numbers, right? Strings, no problem. I'll do something with them, and we get this not a number thing, right? But we don't want people to go and use our function later. Like this function could see widespread use. It could be used by developers who aren't even part of the company yet, who aren't even working on the app yet, right? And they'll just come to rely on this. JavaScript has no problem with doing subtractions on like all sorts of random stuff, right? But maybe we should. Maybe we should care whether or not someone passes like an object or a string or something to this compute score function, right? Maybe we should notice and say like, excuse me, you're not using this right? Maybe we should create a constraint. So one way to do that is maybe we leave a comment in here. Right? That's one good way to kind of capture intent. Listen, I, the developer of this function, decided that you should only pass numbers here. So anyone who goes and looks at this function is going to see that, oh yeah, okay, so I have to make sure that whatever goes in here is like number, right? And that's great, but one of the almost said downcomings. One of the shortcomings of this is that probably a lot of the people who use this function aren't going to, they're not going to actually look at the source, right? Like, how many of you have looked at the jQuery source code for like what document ready does? None of you. I haven't. We just use it, right? We learn what parameters we need to pass to it, what constraints are built around it, and then we do that, right? So we look at some documentation. Maybe you put this on some wiki page for someone to see. That still doesn't guarantee that that this function is only going to work on numbers. So maybe what we want to do is create some sort of warning, right? Let's say we go Earn by single quotes. But we don't want this to run every time, right? We only want this to run under certain circumstances. So what do we want to do here? If statement, yeah. So we want to warn the user if they're using the function wrong. So we need to do some sort of check. What should we do? Let's type out, am I doing that right? Yeah. Yeah. Like that? Is that what you had in mind? Bigger? Okay. So I put 1 into A, I check the type of A. It gives me back the string number, so I compare that with the string number. And indeed they're equal, right? So I think what I want to do is, if it's not a number, not the value not a number, but if the type of upvotes is not a number, or the type of upvotes, downvotes rather, is not a number, then I want to do this console log, right? Okay, so yeah, now we have a little bit of, we've captured in the code, so it'll be hopefully visible to somebody using this function that hey, there's something you need to know here, and if you're doing this wrong, I want you to know you're doing it wrong. So if we run this function, if we did this right, then we shouldn't see it come up, right? Because everything we're passing is a number. Yeah, okay, cool. So we got our warning. Good stuff. There's still a problem. What's the problem? It's still showing out a number, exactly. Why is that bad? Yeah, it didn't solve the problem, right? So we just said, hey, excuse me, oh, okay. And then it just like did the bad thing anyway, and you got not a number, and then now somebody using your app sees like not a number on the page, and they're like, what? Or worse, like something else bad happens, right? Maybe you end up putting like bad data into your database, right? Maybe you end up making like maybe you're betting like bitcoins or something on like the scores of posts, and somebody got like some janky, like some people lost money, right? Because you didn't handle this case. So we can do a little better. That's a little better, right? Now we get undefined back, so it's only a little better, right? This is where it might be a good idea to create our own custom plan for handling errors. And it's pretty easy. You see how return here is red in my text editor, and it's probably a different color in your text editor. But what does that mean? Hmm? Two return statements? No, that was a peace sign at NEMA. But I understand your confusion. So return is red, if is red, function is red. Why are those words red? Const is red. Their functions are objects or something. No, but right ballpark. It's because they're keywords, right? They're special words that have special meaning to the JavaScript interpreter, right? So I'm going to show you a new one. Has anyone seen this guy before? Yeah? What's throw do? Usually throws an error, yeah. Yeah, if you don't know exactly what this does, then maybe you've at least sort of heard the phrase throw an error. And maybe you think of like, well, throw a ball or throw a tantrum or something, right? It's kind of like that. Um, but yeah, it means we're gonna throw an error, right? And when we throw an error, we need an error. So in this case, my linter is telegraphing what I'm going to say next. Don't read that. Now when this code goes wrong, we actually throw an error. Like the code stops, right? It pulls the fire alarm. Hey, something's wrong. Stop what you're doing. Everybody out of the building. Right? So we see 30 logged out, no problem, right? So 40 minus 10, 30. This one didn't log, and furthermore, everything else stopped. Right? I got throw. Hey, don't pass things that aren't numbers. You see we got a line number, right? Line 10, it said I threw on line 10, and this is the thing that I threw. But hey, where's our stack trace? Where's all that juicy information about exactly what went wrong, right? Because it's not just that it's on line 10. If we look at line 10, we say, yep, there's a throw there. But the error isn't here. The error is somewhere else. So we look up here. We go, okay, so we're checking to see that the type of both parameters is a number. Then we look at the parameters, and if all we know is that the error occurred on line 10, that's all we know. Right? We can't trace further back because the things that come into the function are coming from somewhere else, right? So we want that stack trace. We want to be able to follow it back and find out that, oh, this is the problem, right? So for that, we want an error object. And those are pretty easy to create. We don't want to use an old hand-me-down error. We want a new one. It's just called error. Error is a class constructor, right? So sometimes you go new whatever. Have we used the new keyword for anything? Does that remind you of anything that you've seen before? Or is this a totally new concept right now? You've seen it before? Can you think of anything that you've used it before? Just to kind of help me understand what to compare it to. New date? Okay, yeah, interesting. Yeah. New date. So how's new date work? And that's like kind of a hard question, but like what happens when you type new date? Mm-hmm. Yeah, that's about the level of resolution that I was going for. Is yeah, when you go new date, it creates like a date object, right? Like if I go, like if this was a string, it would have like quotes around it, right? So this is like a string object, and you can see the string in there. But this is like some sort of other thing, right? That like the representation in the console is, this purple thing. But yeah, with the new date, you can do things like interrogate what time zone it was created with, and probably some second and third thing that I don't know, can't think of right now. But yeah, it's like an object that has complex state and behavior, and like it does more than just what a primitive string or a primitive number does, right? So a new error is the same thing. One thing that it contains is a stack trace. I'm gonna make that just a little smaller so I can fit more of this on the screen. Is that still okay for you? Cool. So yeah, same thing. We got out 30, and then we hit the problematic thing, right? We saw that it's on line 10. I threw a new error. And then, yo, here's the error, right? Uh, hey, don't pass things that aren't numbers. That's the message. So good errors have a message. And then we get the stack trace. This happened in the function compute score. Well, what was using compute score? Something inside of a for each loop. You called for each on something called post scores dot for each, and that had a variable called score set. And that was on line 16, so something went wrong there. And then this is like, that referred to the for each method on the arrays prototype, whatever. But basically, this is only 2 layers deep. So as far as like our application is concerned, like the code that we wrote is concerned, this is only 2 layers deep. So we can see not only did this happen in the compute score function, but that it happened while we were iterating over this post scores array. So that lets us go, okay, so like what was passing the wrong thing to compute score, right? We can go and look, let's say line 16. So you can go look at line 16. Okay, we were doing compute score. And then, oh, this is where the upvotes, downvotes come from. Okay, I see. So I have to go check my data. So then I can just scroll up here and look at like, look at the array itself. But if I couldn't, then maybe I'd just put like, I'd put one of these in here. Like suppose this comes from a database or an API call and I can't just like scroll up and look at it. I know that the error occurs in here. It's like this data is bad somehow. So I'm going to go ahead and look at that. Then now, boom, I hit the same error, but I scroll up and I can see, oh, okay, just before that error hit, I had a number and a string, and that's what caused the problems. And that lets me fix it. So when I have the stack trace, when I throw like an error object, it lets me go back and go back and go back and pinpoint exactly which part of my code is going wrong, or which part of my data in this case is wrong, right? Cool. Any questions so far? Okay. That's good. That must mean that you just like are all grasping this. Way ahead of me, maybe. Okay. Okay, let's pick up the pace. So have I convinced you at least that having errors in your code that you write yourself is actually a good thing? Does it make sense why you would want something like this? How this helps you from it prevents you from introducing bugs during development. If bugs are introduced, it helps you track them down. Is it clear why this is a good pattern? Okay, cool. Is anyone not convinced of that? Is anyone going to go back and be like, more errors? I don't want more errors. I get enough errors. Okay, so your midterm projects are going to be full of like, throw new error, you're not supposed to do this. You're going to see like half your code is just going to be like error checking, right? Cool. One thing I want to flag here is this isn't really, we could improve this message, right? You know how you can name variables whatever you want, but they're like good variable names and bad variable names? Same kind of idea for messages. So even if the message is bad, right? It's not a helpful error message, but we still get the stack trace, and that's very helpful. We can still give the developer big hints about what's going on, right? So before I had to like do some sleuthing and find out, okay, where exactly is my data going wrong? I can shortcut that for the person doing the debugging by just giving them more information about what's going on, right? So when we're deciding what information to give with an error, we want to give what it was that went wrong, where it went wrong, and what data was involved. Right? Which one of those 3 things tells us what we did wrong here? What it was that went wrong, where it went wrong, what data was involved. Yeah, what data was involved? I mean, all three are useful for sure. I like the very general guesses that I get from the front row. It's like all three of them are important. Yes, now you're thinking. Um, yeah, in this case, it was a data problem, right? So in our error, we can shortcut the debugging process just by making it visible what the data is, right? So I want to say, okay, this is where things went wrong. I'm going to use the word compute score. Even though it's in the stack trace, I'm still going to put it in the error. Um, so I say this is an error, so obviously that didn't work out. I'm going to say so I'm going to interpolate upvotes and downvotes. I'm going to interpolate my parameters into the error message itself. So now when I look at the stack trace, I can see like, okay, that's a number. That looks fine. That's very, very obviously not a number. At least not a value of the number type in JavaScript, right? Um, so there's my problem right there. So I prefer for you to write your error messages like that. How much time would that save me? Just kind of like tugging on threads and like going like, where does? Okay, so this goes into here, and like if I just saw this right here, oh, I'm receiving bad data. Yeah, so hopefully it makes sense that this is like a thing we'd want to do. Uh, that we'd want to when our app is being used wrong, when our code is being used wrong, that it'll let the developer know. I'll say, hey, that's not how. Put that down. That's not how you use that. Let me explain. Do it right and it'll work great. Do it wrong and I don't want you to do it wrong and then like way later down the chain you run into problems. I want you to know right now this isn't how you use it. And there are a bunch of ways that we could do this. Like maybe we want some constraint that says this function should only receive two parameters. We might have a constraint that says if a number is bigger or lower than this amount, you should be concerned. Right? We can have all sorts of constraints and we can just put them at the top here. Right? And we could throw different errors for each thing. And that's a great way to write code, especially if it's library code that people who you're not even going to meet are going to be using. It's a great idea to like, you'll look at the source code for like something like jQuery, and in the source code it'll be like error, 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 error. And then like way down at the bottom, you'll see like the code that actually does the thing you're looking at. That makes document ready do what document ready does, right? Where it'll say like, you pass the window object, not the document object. You pass the string document instead of the object document. Like all these different things that can go wrong. They have like at the top of the function, and then they have the code that does the business. So that's a good idea. But the skeptics in the room, and I can feel you feeling skeptical. The skeptics in the room are still thinking, okay, so that sounds great, but like I'm gonna put my app out on the internet, and how often does your Facebook app or your Yelp app or something just like blow up and be like, Yelp is out, something went wrong, like I'm gonna blow up. Maybe that means that Yelp doesn't have any bugs. False. Yelp has bugs. Um, so if that's the case, if Yelp has bugs, but also it doesn't blow up every time something goes wrong, then what's going on? Maybe they just don't write these errors. That's not the case either. Um, in the same way that we can throw errors, and it's like throwing a tantrum, like a toddler throwing a tantrum, we can handle errors, right? Like a toddler whose parent is nowhere to be seen, just like throws a tantrum and everybody's like, just waits it out, right? Ruins your whole dinner. Um, but if the parent's around, they'll handle the tantrum and prevent everybody from being affected by it, right? So the default plan for errors in JavaScript is it just goes up the stack, up the stack, up the stack, up the stack. Do you have a plan to handle me? Do you have a plan to handle me? Do you have a plan to handle me? If it gets all the way to the top, it goes, no one was prepared to handle this error. I guess that means I'll crash. And for most of the time, that's the way we work. We just like don't handle errors, and if an error comes up, we want to know about it during development, so we just let it blow up. But in this case, suppose that we know that this data is unreliable, right? Sometimes we're going to get strings in our post scores, and there's nothing we can do about it. That comes from like some other company where they're drunk all the time, and we just have to cope with that. So we want to keep computing these scores. We just um, when we get a bad one, we just want to throw it out. Don't explode. Just don't use it, right? So when compute score runs, we want to be able to say, okay, just do your best. Just try. And if an error is thrown, I'll catch it. Right? So I'm going to say, I want to find the point here where if something goes wrong in this part of the code, I'll just handle it, and then the rest of the code can get on with it, right? So in this case, I think if one of these compute scores fails, I want the rest of them to be able to keep going. So that means each time compute score is run, that's another instance of just try your best, and if it fails, we'll handle it. It's actually not try your best, it's just try. So who wants to take a stab at what's going on here? uh, you're technically not wrong. It tries the console log, and if it fails, it catches the error. Ah, yeah. So if there's an error, it'll be passed into the catch block, right? So this almost looks like a function call. And this is some special JavaScript syntax, right? It's not exactly a function. You can't just say catch anywhere. Yeah, it's sort of like a function call. So if there's an error, and we see that behavior of the error where like normally when a function returns, it goes back up to its parent, and it's like here's the thing that you asked for, right? And an error kind of does the same thing. It's like an escape hatch. It's kind of like a return value, right? So if when this line is evaluating, something goes wrong in there, then that error is going to come up, just like the return value of a function, right? And if this turns out to be an error rather than just everything going as swimmingly as it can, then the catch block will run, right? So this looks kind of like an if-else in a way, right? And it's not an if-else, but it is like flow control, right? So in if-else, it's like if, then some brackets, else, whatever. Here, it's like kind of in reverse. So it's like if, then some expression, do this, and if this is false, do this. In this case, it's like you're definitely going to do this. Under certain circumstances, you're going to do this, right? So what might we put in here? Any ideas? Your what? How you're going to handle the error? Yes, absolutely. Pardon me? Throw a new error. Good guess. I think in this case, we don't want to throw new error, but one thing we could do is like, if we get an error from here, we might say like, this error message is not really descriptive for like what's going on here. Like I know that this data is bad, and so I want to tell the developer like, oh, it's just one of those post score things, instead of whatever compute score says, right? So I might throw a different error. That's not a very good error message, but yeah, you might want to like recontextualize the error. So then this is still gonna error, right? It's like you caught an error and then threw a new one, right? Another thing you can do is say, well, I don't want the whole app to explode, right? But what I do want is for I do want to capture that somewhere, right? Right? So I might log out the error. I want to know if this goes wrong. But I don't want to log. I probably want to warn. I probably want to error. Right? Do you know about this? Okay. Cool. Zoom in a little bit there. Yeah. So if we console log, that just looks like a string into the console, right? But we have like a bunch of console stuff, right? Look at all these things you can do with the console object. So included in there is warn. Right? And now this looks like a warning. Like it's visually distinguished from the regular console log. And error is also visually distinguished, but it also has a bunch of behavior, right? Remember how just throwing a string is like, okay, great, a string and a line number. But throwing an error gives us a stack trace. This gives us a stack trace too. And this is a boring stack trace, but it's there. So my recommendation is going forward, you probably want to always pull out console logs from your code. My rule is I always pull out console logs from my code. If I do want something logged into the console, and that's not just like I'm just kind of shining a flashlight around while I'm developing thing, it's like I want this in the console when my app is in production thing, I use console warn, or I use console error. Or I use console info. And info looks a lot like log, except you have like this icon that says, this wasn't an accident. I meant to put that there. So my linter always warns me about console logs, but if I change that to console error, does it warn me about that? It also warns me about that, but it's not supposed to. So yeah, my recommendation is use logs for development, use error, warn, and info for everything else. Yeah, so any questions about try catch or anything we've talked about before we take a break? If we had, the question was if we had an error, throw error in the catch, would make the first one redundant. Not really, but it does overwrite it, right? So we'll see. Let's say the catch block is just empty here. Just nothing happens, right? The bad value is just not there, right? So what that tells us is that the thrown error doesn't actually make it out. It doesn't make it to the top level. It doesn't crash the app. It doesn't even make it to the console because we didn't tell it to. It's just not there. Um, so when we throw this error, we don't see the original error. That error is gone, right? That was eaten by the catch. What we do see is the new error that we threw, right? So if there was something out here, we just have an empty catch block. Yeah, it only works. It only works when it's coming from that specific place. Um, yeah. So if you wanted a specific error where you wanted to say, look, if this catch block hits, I don't want to give you the actual error. I want to give you this error. Then you can override it this way. Otherwise, this error is still useful, right? Like if we don't throw this error anymore, then this catch block doesn't even run. We just get not a number again. It's like nothing even went wrong, right? So we need something to go wrong. We need compute score to pull the fire alarm, so that this its parent, its caller, knows that something's wrong. Otherwise, the catch block doesn't run. Does that help? Cool. So let's take a break. I'll see you all in like 10 minutes or something. Yeah. I think I was waiting for a scarecrow, but it's just like a pile of coats. Yeah, I think that's just a pile of coats, right? That doesn't like that's not a placeholder for a person. Right. Okay. Okay. So yeah, we would have been waiting a long time. Okay. While I get the stream started up again, let's just take a moment to read this code and think about what it does. And I'll actually turn on word wrap. Normally I hate word wrap, but you should be able to see the whole thing. So who wants to talk me through what this code does? A random person is selected. That's true. Right. Right. And leaves the tip up to the payer. Right. So one thing that I noticed that's interesting is that I'll kind of like skip to here, right? It's kind of when you're talking about like what this does, kind of skip to here. But like none of this works, of course, without the stuff above it, right? So all of this code from line 9 to I guess just line 10. Right, it's just 2 lines. Um, line 9 and line 10 don't work without the preceding 8 lines, right? Yet we're tempted to jump to the end here. We know like okay, I have like some dependencies, right? But like the real meat of what's going on is over here, right? Um, but yeah, so what's going on is we capture the total bill. You can think of this as a dollar amount. Um, the tax rate in your location, or in the location this program's written for, and then a list of diners, a list of names, and then with the diners we can compute random index that we can later use to select them, right? So this random index has a dependency on diners. So it's a good thing diners is up here and not at the bottom of the file because that wouldn't work. Um, and then we do a calculation where we take the total bill and the tax rate. And those are up here, so that's good, right? So like none of this would work if I did this, right? All of this would break. Why? Calling variables before they're declared. Exactly. Exactly. So we kind of have this intuition for what before means, right? Before means above in reading order, like a book. You read left to right, top to bottom, right? But computers don't have to work like that. That's a decision that language designers made so that it would be intuitive for humans to read code, right? That we'd start here. This would be the first line that runs. It goes, oh, okay, yeah, I'll read it left to right, just like I'm reading a book, top to bottom, right? And so anything down here that has a dependency must be able to look up to find its dependency, right? So we have this like line by line thing where before is up at the top and after is down at the bottom. And so the dependencies go top to bottom like that, right? That's hopefully by this point in the program, that's so intuitive you just don't even think about it, right? Um, but there's a name for this style of programming, and the reason that there's a name for this style of programming is because there are other styles of programming that sort of challenge that intuition in some cases. And you've been exposed to them, to some of them, as we'll see soon, even if you don't know it. But this style of programming is called procedural programming or imperative programming. What we're doing is we're defining a procedure. First do this, then do this, then do this on the next, like one line after the next, right? And it takes some amount of computational time for the JavaScript interpreter to go, okay, I see I'm creating a new variable, and it's a constant, and it's, you know, I'm getting some string, because like this is just a text file is just like a string, right? So it sees this as a string first, and it goes like, oh, there are no quotes around it, and the first digit is the first symbol is a number, so maybe this is a number, and then it like parses it, and like it takes some computational time for the JavaScript interpreter to figure out what this line means. But we know this line's going to run, and then this line's going to run, and then this line's going to run. It's always going to go in order, right? So each line is just going to wait for the next to run. That's just how procedures work. First do this, then do this, then do this, right? So everything stays in sync just from top to bottom like that. But we're going to talk about promises. And promises are one way in which we defy that procedural imperative programming paradigm. And we don't totally do away with it. We just kind of don't think of it as the default way to be. We think of our application as having like little parcels of imperative code. But the whole system isn't necessarily imperative. It's not necessarily procedural. So when we run a program like this, you know, it looks at the floats. It looks at the first line and it runs it. Second line it runs it. Third line it runs it. It keeps going until it's out of lines, and then it exits, and it's like, how'd I do? You go, great, good job, Node. Good job, demo.js. But how well does this concept map to, say, a web server? Can you think of a web server in terms of, I have this system that's just it's gonna run each line of the script and then exit? Can you make a web server like that? Not really, because what's a web server do? It always keeps on running. Yeah. Yeah, exactly. A web server keeps running, right? If a web server does nothing else, it listens and it responds to requests, right? And one of the things that means is that you don't know, like when you first start running it, you don't know when you're going to get a request. You just have to be ready to, when a request comes, this is how I respond, right? And so this plan doesn't work anymore. We need some other, like we can't just run a script and hang out, right? We need some plan for organizing this, like, you know, this procedural task that we know how to do into this event-oriented kind of like this thing that has a time component that this sort of script doesn't have, right? How about a user interface? We're getting some experience programming user interfaces, right? Your Tweeter has a user interface. Your Tiny app has a user interface, right? User interfaces have buttons. They have fields. You might have like a message pane where messages trickle in. You might have notifications and alerts, right? Can you just build a user interface just like line by line like this and then say, okay, done. Here's your user interface. Let me know if you have any problems with it. You can't. Your user interface is listening, right? You have buttons that are waiting for a click, right? You have buttons that cause network requests, and you have to wait for those network requests to return. And then when they return, you can create objects on the page, but first you have to make sure they're there. And you have all these dependencies that sort of sit next to each other, right? So I'm going to switch to the whiteboard for a sec. That's not right. So you can kind of think of like this script here, right? The bill resolver thing, it has a step, and then another step, and then another step. So it does a step, then does a step, then does a step, then does a step, and it's out of line, so it goes home. Right? So you run it, it does its thing, and then it exits. Right? If the thing that we want to do is build an application that users can stare at for what in computer terms is like centuries, right? Like if you just have like an app sitting on your phone or on your computer, it's just like sitting there waiting as the years tick by in computer terms, and then finally a click comes, it goes, oh, and it does the thing for you. This paradigm doesn't work. You can't just like run a script and then exit, right? You need to program in these behaviors that will wait for a certain trigger to run, right? So you have, you have like a button where, you're going to click on this button, and then that button's going to make a network request, and that network request is going to put a DOM element on the page, right? And that's one behavior. Then elsewhere on the page, something that has nothing to do with this, right? It's going to be like a field. And every time you type a thing into a field, it's going to compare that to a regular expression, right? That regular expression tells you whether or not there's like an @ sign in there. It ends in like a valid top-level domain because you want to figure out if it's an email address or something, right? And then there's like a branch here where it says, it's going to tell you either like, yeah, it's a good email address, or no, it's a bad email address, right? And that's different from the button behavior, right? And all of this kind of becomes like its own system. You have all these different behaviors kind of floating around in a web app, right? Same thing with a web server. You have a network request. Someone goes to /users. I want to go get a collection of users and return it to them. Maybe it takes me a little while to go get a collection of users, right? So like while I'm in the database, another network request comes in. And they just want to know what time it is. And it's like, oh, I don't have to go to the database for that. I can just tell them. It's like while you're in the database, your web server goes and just sends them back the time, right? So you don't have to wait. Right? So while you're validating this email address, if a button click comes in, the program doesn't halt, right? If it does, this is especially obvious with animations, or if you're not thinking asynchronously, right? You have like a, this is going to be my little animation drawing, right? So maybe you have a little spinner or something, right? And you click a button that makes a network request, and if these aren't asynchronous, the animation freezes. You can't click buttons. You can't enter anything into forms, right? Everything just freezes up because you have to wait, right? Because these behaviors aren't separated. We don't want our systems to work like this, right? We want our systems to work asynchronously. We want these things to be dependent on each other where they need to be, and otherwise separate, right? So in JavaScript, asynchrony is the default, right? In JavaScript, asynchrony is the default. That means when we do something, when we give JavaScript permission to be asynchronous, it'll be asynchronous, and it's our job to build systems that say, okay, this part's synchronous and this part's asynchronous, right? So this part's synchronous, but the system is asynchronous. Does that make sense? I know I'm getting kind of abstract here. Give that a moment to sink in. Any questions bubble to the surface? Or perhaps I've completely lost you at this point. Okay, so let's get rid of this. Can someone give me an example of an asynchronous behavior? Ajax request? Sure, great example. jQuery, does that look like? Does it look like that? $.get, and you pass this like a path and a function. Function receives a response as a parameter. typed out response, I can type out error. Okay, so the hard part of asynchronous code is setting up your dependency chains, right? So in this case, there's a dependency implied here, right? Without even knowing what this function does yet, what we know is that all of the stuff inside of this function depends on the response from this route, right? So we can start making assumptions about what routes have what, or what behaviors have what dependencies. So for example, if what we're trying to do is like create a bunch of user cards, like we were talking about before, then we can't do that without the users, right? Like it's nonsense to try to create user cards when you don't have any users. Like that doesn't make sense, right? We're saying in our system, once you have users, here's a thing that you might want to do, right? So our response might be like, so the way that you've been doing this so far is you use callback functions, right? So that can just be like a function that you declare elsewhere, right? What did I? Yeah. So the way we've been doing this so far is with callback functions, right? And so what callback functions do is they create like this kind of nesting, right? Where you make a function call and it's like get creates like this function scope, right? And then get knows that when it's done doing what it's doing, there'll be like this callback that's supposed to call, right? And then that callback, if you have to make subsequent asynchronous requests, and that'll receive a callback, and you get like this kind of like drilling in thing, right? And that's how callbacks work. And this should be mostly review today, right? Yeah. So promises kind of take that, like it's sort of weird that this function like has to know, like it gets like all of this scope and all of this scope, right? And it's kind of weird to think about this like this as a subprocess of this as a subprocess of this, right? It's more like steps, right? So if we look back at our like our bill resolver code, right? It would be sort of weird to think of to think of the bill calculator, like the random index chooser, as a sub process of like the list of users, right? It's not like really inside in any way, right? It's just they're just like next to each other. They're just like a sequence of things, right? So what promises do is they let us take these things and make them look like this. First do this, then do this, then do this, and that kind of purposely looks like these. That's what I was setting up. So callback land is like drilling down, and promise land is changing. Not changing, sorry, chaining. We create promise chains. So if we were going to refactor this to look like a promise, switch to the fetch API. I'm going to demo fetch real quick. So I don't have to write like pseudocode. I can just write like real code. So fetch works like this. Fetch is great. It's built into your browser. And it's an easy way to make network requests, make AJAX requests. We didn't used to have it, which is why the jQuery, like some people would import jQuery just for like the AJAX calls. We don't have to do that anymore. We can just use fetch. Fetch has one weird hang-up that I'm going to talk about. But we'll see why that's not a problem. So how fetch works is you pass it a URL, and that's it. But what fetch does is fetch uses promises, right? So let's take a look at what that looks like. So I have this app called, did anyone look at Good Words? This app I made? Um, it's a really simple app. You type in a word. What word should I type in? Any word will do. And it just goes to the Oxford Dictionary API, and it gets the definition for me. You can string words. I'll put a bunch of words on here. So basically, I have an Express server running, and that Express server talks to the Oxford Dictionary API, gets a response from there, gives it back to the server gives it back to the client puts it on the page, words. So it does that. It does that by using fetch. So it does something like, I have this route like words and then like some word. So let's say, so I have a route like this. So in my Express server, it looks like word/word. You know how you might have /ID? You can just make that whatever you want, right? So I made it word. So when I make a fetch request to words, well, calling word isn't going to work, but maybe word will work. Fetch gives me back a promise. Just kind of tells me one thing about it, right? That it's pending. What happens if we put that in a variable? We can go I did that already. Okay. So it was pending before, now it's fulfilled. Knowing what you know about AJAX requests, what do you think that means? Any ideas? Probably means that the request was successful. Yeah, yeah. It certainly means that the request was completed. I think fetch has a quirk where if the request fails, I don't know if this is true or not. Let's find out. Yeah, if the request fails, it'll still say fulfilled, right? And not all libraries do this. But like we can interpret this sort of like, yep, that request successfully 404'd. Just sort of weird. Maybe in your opinion that should be an error. But that's why you can throw your own errors if you don't like that. So we know that if we, if I type, word in here, I should get, yeah, there it is. Word's got a chunky definition. I know that if I'm doing like this kind of fetch, then I need to be able to get at this data somehow, right? And the way to do that is with promises, by interacting with promises. So with a promise chain, what you do is you chain behaviors on the end of a promise. So a promise either resolves or rejects. I just realized I was showing the whiteboard on the stream this whole time. Yikes. So usually when we're talking about promises, we're talking about like a library gives you a promise, like fetch returns a promise or connects returns a promise or something. So you end up with a promise. You don't create it yourself. You can create it yourself, but usually a tool you're working with gives you a promise, right? So what's going on inside that promise, like we don't know. There's like some database driver that's like going to talk to a database, or there's like some TCP driver that's making a network call or something. There's a bunch of like crunchy asynchronous stuff going on. But what we do know is that a promise either resolves or rejects, right? So instead of returning, promises don't actually return. They either resolve or reject. So what resolve does is spooky stuff, and then you either resolve or reject. What resolve does is it comes out of promised land. And if there's any dot then at the end of the promise, it executes that. If the promise resolves, it says, well, I'm going to hand off control to the dot then. If it rejects, it hands off control to the dot catch. Okay, keep that basic model in mind. This isn't the whole picture yet, but we'll get there. So if we look at this promise, we have like a dot then method and we have a dot catch method. And one of the nice things about promises is that if you know something is a promise, all you need to know is that it's a promise and you know how to use it. Is it a promise? Okay, good, I know how to use it. And the way that you use it is always the same, more or less. You go dot then, and then it's going to hand you whatever it came up with. And if we don't know what it is, we might just call it result. And this is where fetch gets kind of crunchy. So I'm going to gloss over what's actually going on here a little bit. Just like blur your eyes and go like, yeah, okay, Garrett. And it'll be fine. Fetch returns you a readable stream instead of just like giving you your data. And the reason for that is because fetch wants to be flexible. It wants you to be able to use fetch to go get text or go get JSON or go get XML or go get like all sorts of things. In practice, mostly what you're doing is just getting JSON, right? So you get this response object. And the response object has a method called .json. And what we find out is that .json is another promise, right? So if we actually want to get this data, we just go to the end of the promise chain again. Is that the right spot? Oh, come on. And we get undefined because I did this once already. Okay, I'm going to start over. Let's do this in the text editor. It's a little easier to follow. So we're gonna go fetch, right? Fetch returns what? Fetch returns a promise. Because we know it's a promise, how do we use the promise? We stick a dot then on it. Fetch has a quirk. What's the quirk? Oh yeah, that's the thing I was talking about. That's also true though. Yeah, so one quirk was the thing that I called a quirk earlier, which is that if it fails, it just resolves anyway. But yeah, the thing I was driving at was the thing that you said. which is that the first thing that you get from the promise is like a readable stream, which is kind of like what's a readable stream. Um, and as far as we're concerned, what a readable stream is something that you can call like .json on. And when you do that, this is also a promise. So knowing that this .then returns a promise, how do we actually get at that data now? We call .then. So we can put this on another line, of course. Right? And then here, our data should actually be like the data. Let's see if that turns out to be true. Yeah. So the dictionary API actually gives you like a ton of data. Like it tells you like grammatical features that this is singular. I don't know what type number means in this context, but it gives you like etymology. It gives you like if the word has multiple senses, it gives you all of those senses. So to get this thing that I have on the page here, I actually did some like I have like something where I like traverse the object and find the definitions that I want. There's a little more to it. You get like this huge object from the API though. But yeah, did you notice how we got promise pending and then we got this? Do you notice how there was like that pause there? Let's do it again. Watch for the pause. You see that? So that's just the promise. That's when we did all of this. The thing that this statement, this fetch.then, the thing that evaluated to was a promise, right? And then inside the promise, we had this data, and we logged it at the end, right? So what we've defined here is a dependency chain. Okay. We said that you can't read this stream until fetch returns, until the network request comes back. You can't log the data until you've read the stream, right? And we can do this to create these sophisticated asynchronous behaviors that let us write an app that has all sorts of asynchronicity. But then we say, like, I want these things to line up in order. And to demonstrate that like a little more, like the sort of thing that we might do with this, rather than parse this like huge dictionary thing, we're going to add a route to my server. Just make this an array of users, maybe. That'll work, right? Just people who I've seen today. Restart my server because I don't have NodeMon installed. This is like easy mode, right? You all can spin up new routes in your sleep. Like, it's not even a thing, right? Cool. Let's just check my endpoint. Yeah. Okay, so that endpoint works. Let's do this in the text editor again. Okay, so back in our demo, we're going to change this. This is we're no longer fetching a pineapple. We're fetching users. Pardon me? How does fetch work? Fetch works a lot like it just makes an AJAX request. So when we do this, we should see, I'm going to open my network tab. We Wish there was a way to have both tabs open at once. Maybe there is and I just don't know. So when I do that, if we go back to the network tab, we should see that I've made a request to words pineapple. Does that make sense? So it's just like an AJAX request, like you've been doing for Tweeter and stuff. But instead of receiving a callback function, it returns a promise. So what that means is that once fetch is done, it's not fetch's job to invoke your next bit of code, right? It just hands off the ball, just hands off the result. So like the only thing you need to know about fetch is like you pass some parameters to it. If all you want to do is a get, all you do is you pass the URL. If you want to do a post, you can pass it like some options, right? Stuff like that. But if all you want to do is a get, that's it. So you just need to know that, and then it returns a promise. And then if you understand how promises work, then you just go to town. You just create like your .then chain, right? So we get our users. We're going to do our stream thing. And now we're in business. So we know that once we parse this JSON stream, or parse this stream into JSON, I should say, what do we expect to get here? The names, yeah. So we might call it names, right? Then we can do whatever we want. So what we've done here is we've carved out this nice little area for us to do all of our procedural stuff, right? So what we've done is we've said that this area from line 4 to like anything between these brackets here, this can count on having the data from the users. So that's kind of nice. We don't have to do that sort of like, have you ever done that thing where you create a variable and then you like go and make a request and you kind of try to like make it so that by the time something needs that variable, the data's there? Has that happened yet? Because like you do something like let users, then you go, maybe this is users, then you go, and then somewhere down here you have some code that's like users for each. You do some stuff, and you keep running into this thing where like it says users is not defined, and you're like, but I defined it. You know what I mean? So maybe you do something silly like set timeout. I heard a scoff. Is that because you've done that before, or is that because you find this just abhorrent? But like this is a thing where people will go like, well, if I just wait like a full 2 seconds, then like everything should be there, right? And like, yeah, you're right, everything should be there, but that's not a way to live your life, right? That's playing it really dangerously. Doing it this way, having the code that depends on users in a promise like this does a much better job of just saying like, you know what, this endpoint can take its time, like whatever you need. If it doesn't work, I won't even run, right? I know that I depend on what comes back from this, so I'm not going to run unless it's there. And that's, yeah, that's basically how promises work. How do you feel about this fetch thing so far? Yes. How would you use a .catch? Basically, yeah, what you described. So just as you chain these .thens, you would just add a .catch at the end, and you would get the error. And then maybe what you do is you just throw the error. Or maybe that's a little too explodey for you, so you console error. So you just console error the error. Just let me know that there was an error. Does that help? That'll catch if anything in the promise chain goes wrong. You have to set up the errors. Do you have to set up the errors? Some of them. Some of them. So if there's an error, like if you try to do something funky in here, then you don't have to write any error for this to go wrong, right? This will just throw like an interpreter error, and then this catch will hit. But yeah, if you throw new error, if you throw your own error in here, then yeah, that'll also cause this catch to hit. Um, Usually you see it at the end of the promise chain, because it doesn't really matter like where it is in source order. Like I think, and I haven't actually experimented with this, but I think you can put it just wherever you want. You can put it at the start. You can put it somewhere in the middle. And I think if you put it here, the way that works is that it won't catch errors here, but it will catch anything above it. Um, oh no, oh no, what have I done? Uh, but yeah, so usually you put it at the end because then it catches like anything in the promise chain. Does that make sense? Cool. Um, okay, so the last thing I wanted to talk about, not actually the last thing I want to talk about, the last thing I'm going to talk about because we're out of time, um, is that this pattern here, I generally want you to stay away from because it's hazardous, right? Sometimes you want, when people talk about promises, they often talk about it as like, it's like I'm sending my friend to the store and I'm not going to start cooking until my friend comes back with the chicken broth or whatever. I don't like promise analogies because they make you think about like, okay, so I'm gonna like run into promised land and like grab some data and then bring it back and go back to procedural land. That's not really what we're doing. So I want you to think of like this section inside of the dot then as a safe space where you can count on this code not running until this code is done, right? So you want to avoid trying to get the data out. You want to avoid trying to just dip into promised land and then come back out. You want to think of it in terms of like as much of your logic as you can put inside the promise chain, that you can capture inside the promise chain, the less bug prone your code is going to be. And when you learn React, you're gonna have things like I want to be able to manipulate some other object that lives outside the promise chain, and there's like a whole plan around that. But especially for your jQuery apps, which are procedural by nature, they're imperative by nature, you don't want behavior that depends on this kind of data to live outside of a promise chain. Just think about that. If you're having bugs related to asynchrony, just try to think, what can I put inside of the promise chain that's not in there now? And that's it. We can take a few minutes for questions if you want. Cool. Otherwise, you can catch me for the rest of the day if you want to go in depth about some of this or talk about how it fits into your projects. That's it. I hope that helps.